Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to the week 5 of this ongoing course on understanding and reducing greenhouse gas emissions, and we are focusing on scope 1 and 2 emission reduction through building design and construction. In this lecture, in fact in this entire week, we are going to look at examples of different sectors or type of companies, one in each lecture, and we will try to understand the range of emissions that these companies accrue. And there, along with that, we will see that how building design and construction could have affected or affects the emissions. They could fall in any scope 1, 2 or 3, but how do they affect the emissions of this particular company? So, we will start with understanding the emissions of airport in today's lecture. But before I go over discussing the emissions of airport, we will take a quick recap of what we have discussed in the previous week. We talked about India specific greenhouse gas program, and we also looked at the GHG platform India. We looked at the sector wise and state wise emissions which are available from GHG platform India, and then India specific GHG emission tools. We also discussed about accounting methods and data collection. We looked at couple of calculation tools, and then we went on to see some of the examples using these calculation tools as to how we can calculate the reduction in GHG emissions. This is all we have done in the previous week, and in this lecture today we are going to quickly look at the emissions coming from transport sector overall, and then from scope 1, 2 and 3 emissions for airports specifically. So, now there in some of these case studies there may be generic numbers for airports in general, while majority of the cases we have looked at the audited case studies where people have accounted and reported the emissions from their facilities. So, these numbers sometimes may be specifically for a particular airport, the case study that is being discussed, and sometimes if the study has been undertaken by some organization in general for, say in this case, airports, then there will be generic numbers, but often these are case study specific and they are likely to be different for different facilities, but still they give us a clear idea of what kind of emissions come from facilities. Like in this lecture we are going to look at airports, and then we will look at some of the important case studies to really understand that how the emissions can be influenced. Looking at the transport sector emissions, and this data is for EU, European Union, and for overall emissions, greenhouse gas emissions, if we see, transport sector contributes to around 28.5% of the total emissions, which is a huge, which is approximately 1/3 of the total emissions that are happening in the entire geographic area. Of this transport sector also, we are looking at this 28.5% coming from transport. The biggest contributor is road transport, which is 20%. So, which is a huge contributor. For the remaining ones, the airport contributes to around close to 4% of the total emissions. So, we are talking about 4% out of the 28.5%. So, which is again a significant contributor. So, we are going to go and look at this aviation sector in detail, and within that we are going to look at only airports. So, also understanding that gradually more and more people are traveling by air. Air travel is becoming easier and affordable, and that is why there is a shift of people traveling using other modes to the aviation sector, and that is the reason why we are looking at airports today. Now, where do airports fit in the aviation value chain is what this diagram tells us. If we look at the entire aviation value chain, we will see that there are manufacturers. So, there are manufacturers who manufacture the airframes, the engines, the other components that form the aircrafts largely and other equipments also. Then we have a very strong component of infrastructure, which is where the airports come. The communications, the handling, everything is part of the infrastructure. And then we have service providers, where we are talking about the caterers, the services, the insurance, financial and all that. So, these are the three main service providers that we are looking at, and they together serve the airlines. Now, further down, the airlines serves freight and passengers. So, it distributes freight, transports freight, and it also transports the passengers. This is the entire aviation value chain. Now, if we look at this entire value chain of aviation, we will see that the maximum emissions, the significant amount of emissions from aviation value chain is actually coming from flying of aircrafts. So, if we look at the 100% emissions, in certain cases we will see that almost 90% of the emissions are coming from the flying of aircrafts, because that is where the fuel is being burnt. Now, as we had seen in the previous week, whether this flying of aircraft, the emissions due to flying of aircrafts are scope 1, 2 or 3 depends upon the facility. So, for example, if we are talking about airlines, the flying of aircrafts is scope 1 for them. 100% of the emission due to aircraft flying is going to be scope 1 for the airlines, because it is directly under their control and that is what they are doing. However, if we are looking at say airports, the infrastructure, or for manufacturers, for them this emission, which is scope 1 for airlines, is going to become scope 3. And this is what we are going to see, that what all is part of the scope of airport. However, we must remember that we can take any player out of this entire value chain, their overall emissions remain almost similar, because the total scopes, the total emissions in different scopes will remain the same, just that their categories will change. So, let us look at the emissions for airports, where scope 1, 2 or 3 the emissions are coming from. So, if we look at the quickly going over the scope 1, 2 and 3 definitions, we will know that scope 1 are the emissions that are owned or controlled by the airport directly at the site. Scope 2 emissions are from the off-site generation of electricity, steam, heating or cooling that is purchased, but not happening on site, which is being brought from a different site, off site. Scope 3 are from related activities. They may be directly under control of the airport or may not be under control. So, what the ACI guidance manual says is that it divides the scope 3 emissions further into two categories, 3A and 3B. 3A are the emissions which the airport operator can influence, while 3B are the emissions which the airport operator cannot influence. So, this is how they have divided the scope 3 into 3A and 3B, and we will look at what all activities fall under scope 1, 2 and 3. So, if we are looking at scope 1, we are only looking at the direct sources of emissions. For example, if there is an owned power plant, so some airports across the world, they have their own power plants where they generate their own heating, cooling or sometimes electricity also. Their own fleet of vehicles which is plying inside the airport premises or in a particular range. So, the direct emissions coming from this fleet of vehicles is the scope 1 emission. The activities for maintenance, for example, cleaning, repairs, the emissions coming from them, the ground support equipment. So, besides fleet of vehicles, there are a lot of ground support equipment that are working there for handling the baggage, for handling passengers, for maintenance, for a lot of other things, servicing the aircrafts on ground. The emissions that are happening there, which may not be directly under the control of airport, but may be owned by the airlines and stationed there at the airport, are also coming under the scope 1 of the airport. Then diesel generators for emergency power, fire training equipment and materials, the airport owned waste incinerators. The emissions coming from these incinerators are also coming under scope 1. So, identifying scope 1 is very simple because we will see the emissions happening on the site itself. So, all these different types of activities are coming under the scope 1 for airports. For scope 2, it very clearly writes that this is from electricity which is purchased, electricity generation which is happening off site. But the understanding here is, where is this electricity being consumed? The electricity is primarily being consumed on an airport to condition the building, to lit the building, to provide for artificial lighting, for heating, ventilation and air conditioning, to provide comfortable environment. Largely the electricity is going into conditioning of this building to maintain comfortable environment, plus a lot of equipments that are there for handling freight, passengers. For example, we have escalators, we have travelators. So, all these are going to consume electricity. All of this electricity is going to come under scope 2 emissions. And then for scope 3, there is a wide range of activities, including the emissions which are coming from the airplanes flying into the sky, the takeoff and landing, which is what we know as LTO cycle, landing and takeoff cycle. The emissions during LTO cycle are also included as part of scope 1 for airports in majority of the cases. While the when the plane has taken off, the emissions in the sky are part of scope 3. And then we also have the auxiliary power units of the aircrafts, the landside vehicles that are not owned by airport operator. All these additional items are going as scope 3. The caterers, the emissions that are going to be there because of the products that are purchased to be used in the airport, all that is part of the scope 3. So, some we can influence and some cannot be influenced. For example, if we are looking at scope 3b, then the LTO cycle. So, LTO cycle is partly influenced by the airport because it is influenced by the design, and partly it is not influenced by the airport as it is dependent upon the efficiency of the engine of the aircraft. So, we will see that some are falling in scope 1 or some are falling in scope 3 sometimes, but this is how different scopes are defined for airports. Now, if we look at some of the examples, we will see that this is for Zurich airport in Switzerland, and we will see that the scope 1 emissions are very high because it has its own power plant, furnaces, emergency power, and then there are own vehicles and machinery. But the large amount of emission is actually coming from the own power plant. So, most of the power is actually coming from the site itself, and that is why we will see that scope 2 is significantly lesser. Compare it with the Stansted airport in UK, and there we will see that this is scope 1, where we are talking about the fuel combustion for different processes using gas, wood pellets. There are emissions, fugitive emissions from refrigerants, company vehicles, all those, but majority is coming from scope 2 emissions, which is largely the purchased electricity, the off-site electricity. So, here in both the cases we see that it is about the power that is getting consumed in the airports largely, and there we have to see that where is this power really being consumed. Again, giving you some examples, this is for Glasgow airport, and there has been a proper accounting for that. Again, look at the emissions that are coming in. So, we are largely talking about, so there is a huge component which is due to these indirect emissions, which is purchased electricity, and this electricity is actually going in buildings, again conditioning of buildings. Additionally, if we look at the factors which can be influenced for scope 1 and scope 3, is this additional LTO cycle. Now, I am talking about the influence of design. So, how the airplanes are going to taxi. If there is a longer route for airplanes to taxi, there will be larger amount of emission accruing from the LTO cycle. if there is a shorter route, if it is efficient, then the airplanes will be, the cycle, LTO cycle for airplanes will be much shorter, and hence there will be a significant impact on the emissions of coming from LTO cycle. If we look at the numbers in detail, we will see that the maximum amount of emissions that are coming from Glasgow airport out of the emissions that we have seen is coming from, so we are talking about the aircraft movements, which is largely the scope 3, which we have already talked about. After that, there is passenger surface access, which is again significant. Passengers commuting to and from the airport is passenger surface access. So, this is again scope 3. So, both of these are scope 3, not under the direct scope of direct control of the airport. Of course, part of it, for example, passenger surface access can also be influenced through large scale design. The scope 1 is primarily coming from the utilities. Now, what are utilities? Utilities are all the facilities that are on ground, including buildings and services for functioning of this airport. We are talking about Glasgow airport here. So, we see that there is a significant contribution, close to 10% contribution due to the utilities that are directly under control, which are primarily being run in the building. In addition to that, we have transport, the operational vehicles, the ground fleet as another significant contributor, which we can directly influence. So, buildings and the fleet of vehicles, these two things are what we have to focus on. Let us look at another case study, which is for Edinburgh airport. Again the same scope here, and we will see that there is a significant component of purchased electricity. If we look at Edinburgh airport, you see that there is the prime contributor to the emissions is the aircraft movements, which is going to be around 75%, which is what we have understood earlier. But other than that, there is a significant contribution due to the airport electricity, which is around 5%, which is what we have seen in the previous case also. So, there is a contribution of around 5% due to the consumption of electricity in the airport functioning. Plus, we also have the vehicles, airport operational vehicles. Here we are seeing this, the airport natural gas. So, if there is heating, which implies that there is heating which is directly being provided through burning of natural gas in the boilers in the airport itself. So, this is a clear indicator that for airports other than air travel, if we are excluding the air travel, the most significant contributing factor to emissions is going to be the buildings, the operations in the building and the utility. And we can influence all of that by designing the building as an efficient building. How we can do that? Let us look at a beautiful example of that, which is Mumbai International Airport Limited, and there how they have reduced the energy consumption. Let us look at some of the numbers. So, over the last 4 years, in fact this is before COVID, before the pandemic hit, and we can see that what all are they doing to reduce this scope 1 and 2 is by investing in solar energy. And when they, so there is an increasing number, so they are investing in solar energy, and what is it doing? It is reducing the electricity that is being procured from the grid. So, suddenly we are reducing the emissions, scope 2 emissions which were here, and we are reducing it by almost half, and there is very little carbon emissions or GHG emissions which are associated with solar energy. Similarly, there is a reduction in the requirement of DG set, and then simultaneously what they have done is they have replaced, they are shifting from DG to the CNG, which has a lower GHG emission factor. So, important choices are being made. So, this is one on what type of fuel to consume. The other is that they are talking about some of important design strategies. For example, the airport is well lit. So, there is daylighting available throughout the day, thereby reducing the requirement for electricity. They talk about designing the taxiway in such a manner that LTO cycle is significantly reduced. So, they talk about rapid exit taxiways, which is influenced through the design of the airport itself. So, LTO cycle is again a major contributor of emissions, scope 1 emissions, and this is again influenced through design, not directly building design as such, but overall design of the airport. So, we are talking about some of the design interventions to reduce the electricity consumption of the airport and thereby reducing the scope 2 emissions here. Another thing that they have done is that they have designed the entire Terminal 2 building as a green building. So, the Terminal 2 building is a platinum rated building by IGBC, Indian Green Building Council, and it is consuming significantly lower amount of electricity by through design and as well as construction. So, designing the building in such a manner that it requires less amount of electricity for artificial lighting, for HVAC, for commuting of passengers. So, internally lesser distance has to be travelled by the passengers. So, all these principles have been used in the design of the building and thereby reducing the total emissions from the airport itself. So, together the choice of material, choice of fuel for energy and the building design have resulted in a low GHG emitting airport as a case of Mumbai International. I will stop here, and I hope with this we have been able to understand how buildings and design have influenced the emissions of airports through some of these case studies. Tomorrow we will see another case study. Till then, bye bye.